Jochen, where are we?
Uli, we are here in Munich Freiham. It's a building site on at 50 meters height, and we are on a platform.
Jochen Hölscher, we both don't feel very comfortable. It's really high, it's shaky, and they're doing a lot of installation at the back, but it's really interesting to see. This is a GFRC plate, which is brought in position. That's a different topic, but what interests us here is how do you install it? How is this brought in position? What's the weight of the device?
The weight of the device, of the GFRC element, is nearly 1.5 tons. And the problematic was how can we install it and bring it to position in the hooking system. And so for us it was a challenge, how can we make the placement in the accuracy of nearly millimeters. And for this we need a special machine, and for this we invented a vacuum pump that can flip and turn this GFRC elements.
Interesting. Where the vacuum pump comes from, we talk in a minute. So we have this somehow horizontal at ground.
Yeah.
Then your device allows to tilt it. And then it's brought in position, and then it can be actually brought in, moving in all directions.
It can move in all three directions. It can tilt, it can turn, it can move forward and backwards, so that we have the ability and the possibility to install it with a high precision.
And that's the device which you see over there. And then it's brought into the hooks.
Yeah.
So when the device is lifted, tilted, brought in position, you may need to change direction. And that's something you can't do with a crane. How is this done? So to really get it, say, sharply adjusted.
It's also similar for that we are used to for the installation of the glasses, because you have the possibility with traverse and with a counterweight, so that you can control the position and to move it.
This is the counterweight. This
Yes.
is the counterweight.
And
by that we are able to, say, secure that it stays in position.
That stays in position, and that stays exactly in the position that is needed to install it. Because otherwise, when you only make it with chains and with a crane, then you have not the fully control about the angle and the positioning of the stone. So in this case, it's the only chance to install this kind of elements.
And he's having the remote control to control the whole device. So he's able to adjust it and push it into a direction by remote control.
By remote control, and additionally there are cameras, so that you can see behind the stone if the male and the female of the substructure is fit together, so that you are having the possibility to see from the remote control if all the 6 fixing points are in position.
Cool. This, say, installation technique necessary for this, for the weight and for this system. Where does the vacuum come from?
The vacuum was an idea that we are also used to have it in installation for big glass plates, and we try to make a transfer from the installation of big glass plates to GFRC elements.
I see. And the GFRC elements are tight enough so that the vacuum works?
It works. It's no problem. You can use the vacuum technique for GFRC also, like we are used to do it for glass.
Interesting. And then I understood it has two circles, it has two types of vacuum.
Yeah.
So if one fails, the other one stays and keeps the...
every time a security circle, and it's dimensioned with a security of more than 100%.
And the noise we just heard, the beep, that's actually giving the warning it's losing pressure, so the pump needs to repressure.
Yes, that's the point with the vacuum pump itself.
That's really a cool way of installing a super heavy concrete piece into a high-rise building. Thank you for that.
Thanks, Oli.